In this video, we're going to learn how to calculate the mean with display data. So here we've got a dot plot on the right which shows the weight in pounds of some animals that came to the veterinarian's office. And we want to answer the question, what is the mean weight of the animals? Before we dive into finding the mean weight, let's first talk about the dot plot here. So in this dot plot, each dot corresponds to a single animal. So these 5 dots over 10 pounds means that 5 of the animals that visited had a weight of 10 pounds. Alright, so how do we compute the mean here? Well, we know that the mean of a data set is equal to the sum of the data set divided by the number of values in the data set. So in this case, we want to find the sum of weights and divide that by the number of animals. And the way we can find these values quickly is by constructing a frequency table. Each row in the frequency table will correspond to a column in our dot plot. So we'll start off with the first column here. The first column corresponds to a weight of 10 pounds, so put that in our table, 10 pounds. And what is the frequency? Well, the frequency is the number of animals with a weight of 10 pounds. And that's the number of dots here, 1, 2, 3, 4, 5 dots. So frequency is 5. So that means we can get the sum of the weights of all those animals by just multiplying the weight by the frequency. 5 animals at 10 pounds means 5 times 10, which is 50 pounds. So we'll continue filling in this table, and then once we're done, the sum of all the frequencies will be the number of animals, and the sum of all the weight times frequency will be the sum of all the weights. Alright, so what's the next row? The next row is the next column, which is 20 pounds. The frequency is the number of dots here, 1, 2, 3. And then weight times frequency is 20 times 3, which is 60. Moving on, the next row corresponds to a weight of 30 pounds. How many dots? Well, no dots here, so frequency is 0, and 30 times 0 is, of course, 0. The next weight is 40 pounds. The frequency there is 1, 2, 3, 4, 5, 6. And weight times frequency, 40 times 6, is 240. Alright, down to our last row, 50 pounds. Frequency is 2. Weight times frequency is 50 times 2, which is 100. Alright, so the sum of all the frequencies, 5 plus 3 plus 0 plus 6 plus 2, is just 16. And then the sum of all the weight times frequency, 50 plus 60 plus 0 plus 240 plus 100, is 450. Now this sum here for frequency, that really represents the number of animals. And then this sum over here for weight times frequency, that represents the sum of the weights. So that means the mean is just equal to the sum of the weights, 450, divided by the number of animals, 16. So the mean is equal to 450 divided by 16, which is 28.125. And our units here are pounds. So there we go. There is the mean weight of the animals. Alright, this next question here has to do with a stem and leaf plot. So this stem and leaf plot to the right shows the finishing times in minutes of students running a long race. And we want to answer the question, what is the mean finishing time? Alright, so let's talk about this stem and leaf plot here. This stem and leaf plot represents a data set, and the values in the data set are 2-digit numbers. The tens digit is shown to the left of this vertical line, and the ones digit is shown to the right of the vertical line. So why don't we go ahead and write down our data set explicitly. So the first value here, the lowest value, is 34. And then after that is 37. Then we've got 41, 45, another 45, 46. Going on to the next row, we've got 50, 59, and then in the last row, we've got 63. So to calculate the mean of this data set, we just have to add up all the values and divide by the number of values. So let's add these up. 34 plus 37 plus 41 plus 45 plus 45 plus 46 plus 50 plus 59 plus 63, and divide by the total number of values here. How many? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 values total. Alright, so we punch this into our calculator. For the numerator, we get 420, and 420 divided by 9 is about 46.67. And what are the units here? In the question, we're told that the finishing times are in minutes, so units are minutes. So there we go. There is the mean finishing time. Here's another problem. In this problem, the histogram here to the right shows the height jumped by students in a gym class, and we want to estimate the mean height jumped. Alright, so first of all, how do we read this histogram? Well, this histogram is actually very similar to a dot plot. The only difference is that the histogram is usually used when the data set is more continuous. The base now gives us a range of heights. So for example, this first rectangle here tells us that 3 students jumped a height that was in the range from 0 to 20. 0 inclusive, 20 not inclusive. So our strategy will be similar. We still want to fill in a frequency table. So why don't we go ahead and start doing that. So the range of heights represented by the first rectangle here, that's just from 0 to 20 with 0 included. So 0 is less than or equal to h is less than 20. And what's our frequency? Our frequency is how tall the rectangle is, so 3. And now we want to do height times frequency, but wait a second. Height is a range of values. So how can we multiply height times frequency when height is a range but frequency is just a number? Well, think back to what height times frequency is supposed to represent. Height times frequency, for this rectangle here, the first rectangle, that's supposed to represent the total height jumped by these 3 students represented in that rectangle. So how do we estimate the total height jumped? Well, why don't we estimate a single height for all of the students? So we'll pick out a number from this interval, 0 to 20, which is most representative of this interval. And we'll think of that as an estimate for the height jumped by each of these 3 students. Then we can multiply that number to get an estimate of the total height jumped. But what number should we choose? Should we choose 0, 20, or somewhere in between? Well, 0 and 20 aren't great choices because they would assume that the students' heights jumped are concentrated at one particular end of this interval. It's usually safer to assume that the heights are distributed rather evenly throughout this interval. So really, a better estimate would be to use the midpoint. What's halfway between 0 and 20? Well, that's just 10. So 10 is the midpoint. And now instead of using height times frequency, because height is a range, we're going to use the midpoint times the frequency. And now since midpoint and frequency are both numbers, we can go ahead and multiply them. 10 times 3 makes 30. Now let's go ahead and do that for all of the other rectangles as well. So the next rectangle, height is between 20 and 40. The midpoint there, we can just add them and divide by 2. 20 plus 40 is 60, divided by 2 is 30. The frequency is how tall the rectangle is, so it's up to 7. And then midpoint times frequency, 30 times 7, is 210. Then the third rectangle, 40 to 60, is the range for height. The midpoint of that interval, 40 plus 60 is 100, divide by 2, you get 50. Frequency is how tall the rectangle is, that's up to 6, frequency is 6. And midpoint times frequency is 50 times 6, which is 300. Now the final rectangle, that goes height between 60 and 80. The midpoint is 60 plus 80 over 2, so 140 over 2, or just 70. Frequency, that's how tall the rectangle is, 4. Midpoint times frequency is 70 times 4, which is 280. So now let's get the sums of the frequency. The sum is 3 plus 7 plus 6 plus 4, which is 20. And that represents the number of students. Now the sum of the midpoint times frequency column is 820. And that represents the sum of heights jumped. So then the mean height jumped is just equal to the sum of heights jumped, which is 820, and then divide that by the number of students, which is 20. So mean equals 41. And what's the units? Centimeters. So 41 centimeters is the mean height jumped. So now we know how to calculate the mean with display data. And in the future, we'll also learn how to calculate the mean when we don't have a display, when it's just a table of grouped information.